What?
Yesterday?
No, that was the one from 2 days ago. Okay, you should grab a calculator today, unless you plan on doing all the math in your head.
Of course, I can do that. I have mental math.
You do have mental math. I'm not saying it's good mental math, but you probably do have some. Note, I didn't say it was bad mental math either. I don't know how your mental math is, but your facial expression told me that's kind of what you think it is anyway.
With my obviously I'm only ever like trying to take it off, so.
One more calculator.
Need one more calculator.
You liar.
Let's grab one of these.
Oh, I'll use this one. This is very
She is the one that's the next
Okay, so today's stuff is going to be a little bit similar, but also a little bit different than what we've already been doing. It really is kind of encompassing a couple of different things that we've done, so it's not completely out of left field, but it's got a little twist to it. So far, when it comes to this chapter, we've been working with naming points, lines, planes, segments, rays, all that wonderfulness. And then we kind of shifted over to finding measurements regarding segments. Today we're still dealing with measurements regarding segments, but we're doing them when you have a midpoint involved. Now, even if you don't read the definition, break down the word midpoint. What does mid typically imply? Middle. Midpoint is middle point. So it's when you've got a segment in which the point that's between the two endpoints is in the exact middle. Now, if it's in the exact middle, that means that it's taken this segment, which I'm going to call the segment AB, and I'm going to call the midpoint M. It's taken this segment AB and divided it into two congruent parts, which means this and this can have tick marks on them indicating that they are the same. It means we can say that MA is congruent to MB. We can write that congruency statement. So, we're going to get some problems that look like this today. Given that J is the midpoint of KL, solve for X. Key thing here. It's telling me J is the midpoint of KL. That means I have a segment KL where J is smack dab in the middle of it. Being smack dab in the middle means this is congruent to this. Now I'm told JK is equal to 3x. Is JK the right half? The left? Sorry, that's the left half. Let me do this backwards. The left half, the right half, or the full thing? JK is the left half. That's 3x. It also gives me the measurement for JL on this one. Is that the right half or the full thing? Right half. That one's 15.
Which means that it would be a 5, so x equals 5.
Which means that these two are equal because that's what those tick marks mean. And so yes, we divide and it says solve for x and x is 5. You have to be careful when it comes to midpoint problems for a couple reasons. One, sometimes they like to throw you off by giving you a half and a whole. And two, you don't want to mix them up with the segment addition ones. These pictures for midpoints look a lot like these pictures. Key difference. This one doesn't have any tick marks. This one does. Another key difference. This one I only know the two parts. I don't know the whole. This one, I know something about each part and the whole. If you know something about part, and whole, you do this. If you just know something about the two parts and they've got the little tick marks, you make them equal. So, got a few more problems, then we're going to change it up a little bit. Each of these instructions is sit under the same thing. J is the midpoint of KL. So my picture, for the most part, is going to start off looking the same. I was given JK again. Was JK the left half, the right half, or the full thing? The left.
Yeah, left.
3x plus 5. LJ. Was that the right or the full thing? The right. I missed a very important piece of the markings that go on this picture. If it is a midpoint, I need to remember to put these on there. Is this problem really all that different from this one?
No.
Not really. Those are congruent, so I set them equal and I solve. Subtract the 3x first. Move the x's together first. That's one thing I've noticed is messing with some of y'all. You're moving the plain numbers together first, which while it works, it can cause issues in certain cases. Move the x's together first. If they're positive, subtract them over. If they're negative, add them over. What is 5x minus 3x? 2x. Add the 6. 5 plus 6 is 11, equal to 2x, and divide by 2. 5.5 equals x. Or x equals 5.5. Does the decimal mean I'm wrong? No. C, again, is still under the same set of instructions, so my general picture starts looking the same. That's J, that's K, that's L, that's congruent, that's congruent. Mm-hmm. It says KL. This one's different. This one's purposely different. My instructions are still the same. J is still the midpoint of KL. So KL goes all the way across. J is in the middle. I put the tick marks. But this time it gives me KL. KL is not the right side or the left side. It's the full thing across. All the way across is the 4x plus 2. The other one it gives me is JL. Is that the left or the right? It's the right side.
But it also goes for the left side too.
Yes. In a situation like this, where we're given a part and the whole, we generally are missing something with that other part. If we know both parts and the whole, we do part plus part equals the whole thing. We're missing something over here. But these things mean they are the same, which means over here I can also put 3x minus 7. Now, one common mistake I see people do when they do this is then set an equation 3x minus 7 equals 3x minus 7. That's not going to help you.
You only do that if they're both opposite things to figure out what's the actual.
You only set these two equal if you know them as different things. Yeah. We don't know them as different things, we know them as the exact same thing. You want to solve? That plus that equals the full thing across. It goes back to what we did yesterday and what we did last week. KJ plus JL is still equal to KL. Part plus part still equals the full thing. 3x minus 7 plus. Nick. Please stop with the clicking of the calculator. 3x minus 7 is equal to full thing across, 4x plus 2. Combine like terms. If they're on the same side, you just do what they say. 3x plus 3x.
6.
6x.
6x. A negative 7 minus a 7. Negative 14 equals 4x plus 2.
Which then you subtract 4x from both sides.
Move the x's together first. It was positive 4x, so I subtracted indeed. 2x minus 14 equals a positive 2. Then I move the constants together, add the 14. 2x equals 16, and divide by 2. X is 8. Try out problem D on your own. Can you do this problem first? Yes, go ahead. I'm going to be coming around and checking answers here in a second. I'm just trying to get the problem done for the video before I start walking around.
Oh, that makes more sense. I had to look and like writing. Oh,
I got it frozen.
Remember, it's not covered doing that first.
Okay, what do we get? X equals 10. Beautiful. So, the other thing we're going to see today is something known as a segment bisector. Now, a segment bisector is a geometric figure, aka a point, a line, a ray, a segment, a plane, some geometric thing that intersects the segment at its midpoint. So, in other words, I got the segment here. I got its midpoint. Whatever goes through that midpoint is a segment bisector. Let's say, oops, I need those congruent because it has to be a midpoint. Let's say I have a line going through it. Lines have arrows going both ways. I'm going to put a little lowercase n in it. The segment bisector I would label as the line N. And when I do this, when I name a segment bisector, whatever that thing is that's going through the middle, when I name it, I have to use proper notation. Remember, proper notation for points, lines, planes. Lines, if they've got the little lowercase letter, can do the little lowercase letter with the word line, or it's two capital letters. I don't know what the capital letters would be. They're not on this picture, hence I'm just writing them like right here, and it would be something like that. That's lines. If it's a segment, its name has the bar. If it is a ray, its name has the single arrow, keeping in mind the first letter is the end point. If it's a point, it's just literally point and then whatever the letter is. And then planes, remember you've got planes and then they've got the three capital letters on it. Now I'm going to tell you right now, I'm not going to make a plane a segment bisector. That's kind of hard to draw. That one, you're just not going to see that one. But that is something to keep in mind. The proper way to name it is the word plane with three coordinate points that are on that plane. So, that right there is the segment bisector. And if something is a segment bisector, if you're told line N is a segment bisector, even if it didn't have these tick marks here, it would be telling you they have to be there, because the bisector has to make that the midpoint. So, the other thing you're going to see today is going to look very similar to what we've already done, slightly different. You'll see problems that ask you to identify the figure that is the segment bisector of the given segment, in this case PQ. The bisector is this thing. What's that thing called? It's a ray. What's the name of said ray? Because you cannot write the word ray, and that is not the correct answer, is the word ray. No. MN. With the bar and the single arrow going off to the right. Would it also be an accurate name to call it NM?
No.
No, because you have to start with the end point, the side without the arrow. Okay, so that's the bisector. Now it also says find PQ. PQ is the length going from here all the way over. See that that's 5 right there?
Yeah.
What's that make this?
5.
What's that make all the way across?
10.
10. PQ is 10. Because it's 5 plus 5. Okay, next one. Segment bisector, the thing hitting the midpoint. There's nothing drawn there. A point can be a segment bisector.
So just the point M.
Point M. If nothing is going through that middle point, it is just the point itself. Okay, it also wants PQ. PQ, there's P, there's Q, goes all the way across. That part's 2. That part's 2. Yeah, PQ is 4. Because it's 2 plus 2. Stepping it up in difficulty a little bit. Essentially the same question. Identify the segment bisector, then find the indicated measure. What is the name of the thing going through the middle? Line N. It's got arrows on both ends, so it is a line, and I cannot call it by the name with the capital letters because there's only one point on that line. I need 2. It's line N.
Wait, how's it a line?
It's got arrows on both ends. Okay, that's the bisector. Now I want to solve. Specifically, I want to find MS.
15. Yeah.
Yep. I'm not saying you're wrong, but give people a chance to think. Okay. There's a couple of ways to solve this one. First off, what do these things mean? They're congruent, also known as the same, also known as equal. One way to solve it, and it's the traditional way, and it's probably not the way you did it.
No, I just looked at it. Congruent. Oh, 15.
One way to do it, and you're not wrong, but sometimes you can't do it that way, is why I'm doing this.
Bogus.
Okay, so one way to do it is to essentially recognize if those two things are congruent, that makes them equal. And you can solve that equation. Six x is equal to 27. Divide by 6. X would be equal to 4.5. Is that what it's asking you to solve for?
Not exactly, no, but then you just replace x with 4.5 times that by 6, then minus that by 12, and then you get 15. Like I said.
Yes. But please, give other people a chance to think.
Okay.
And you plug it back in if it's not what it was looking for. Now, when we do that, we will get 15. Alicia is not wrong. There is actually an easier way to do this one. If this means these two things are congruent, this one's 15, doesn't that mean this one's 15? Sometimes you can do it that simply. Not every time. I like to teach the universal way, even if there's a shortcut. I mentioned the shortcut, but the universal way is good for problems like the next one.
Well, yeah, but...
Yes, if you know the shortcut, you can use it. But sometimes the shortcut messes with people. That's why I teach the universal way. Okay.
Oh, shut up.
Okay, second one. Also asked me to find MS. Also asked me to identify the segment bisector. The bisector is point Q here. We are on page 10 of our notes. We're on page 10 of our notes. Okay. Now, ones like this, I can't just simply do what the shortcut is over here, because I don't know either of these as a single number. So if I want to solve, I have to use the fact that these markings mean they are the same, aka equal. So I can write the equation that says the first one is equal to the second one. And I solve. I'm going to move my x's together first. Since I see there's a minus 2x, to undo minus, add. Be careful of that. 7x minus 3 is equal to 11. Then I add the 3. 7x is 14. Divide by 7 and x is 2. Sometimes it'll just ask you to solve for x. Sometimes it won't.
The back page of 1.3, correct?
Yes. If it's not what it asked you to solve for, you'll have to plug it back in. But ms goes from here to here. Do we have an expression that goes for all the way across? No.
Which means you have to basically do the same thing you did, except instead of equal, you just do one of the equations, then you have to add that twice. So basically times by just after.
So our option then is to plug this back into, I plug it into one or the other or both. I'm going to plug it back into one. I'm going to plug it back into this one because it looks easier. That's m cubed. 5 times 2 minus 3. That's 10. And 10 minus 3 is 7. This distance is 7.
14.
I could plug back into here as well, or I can just use the fact that if that's 7, this is also got to be 7. And therefore all the way across is 7 plus 7, which is 14. The last two problems here are going to be problems that are really trying to make sure you're paying attention. Because they have these pictures here that look like there's a lot more congruent things than what they are. It does, but the people tend to get the wrong one. MN bisects AB. When it says MN bisects AB, that means MN is the bisector. You don't have to write this every single time. I'm just writing it for this first one so we have it in our notes. It also means that AB was the one that was cut in half. If AB is the one that is cut in half, here's AB. This and this are the congruent segments. BE is congruent to EA. We do not know the same thing about ME or EN. We know nothing about their length. They look like they could be the same. We are not guaranteeing that they are. They actually might be vastly different. The picture is just there to kind of give us an idea of the intersection. These problems are going to give you a length for all 4 of those. 2 of them are there to throw you off. The 2 I want are BE and EA. Do we know the length of BE?
No.
Yes.
Yeah.
We actually do, because BE is the same as EB. Not 2x, that's AE. BE is 8. And if it is congruent, that means it is equal to
2x.
EA, which is the 2x because that's AE. You were just ahead of us.
Yeah, I finished.
Solving for x.
X is 4.
4 is x is 4. Once solving these, you're doing the same thing. You just have to be careful on which one got cut in half. Final problem. PQ bisects RT. Which one got cut in half? PQ or RT?
RT.
RT.
gives me one that
Which
gives me
means
that.
this is congruent to this. RE is congruent to ET. And you don't have to write that every single time either, that congruency statement. It's just there to give us an indication of which ones we want. RE is 12. Equal to. ET is, oh, there's a typo here.
Typo?
Oh, no, there's not a typo here.
You just confused me.
I confused myself. I got ahead of myself, don't mind me.
You're confuzzled.
Wait, what? Okay, hold on, I just processed what you did.
Okay, so RE is 12 is equal to ET. Do we have a length for ET?
Yeah,
No.
RT.
We have an RT.
So wouldn't that work?
RT goes all the way across.
RT plus RT.
We have this situation here. I'm just going to separate this from the picture. Yes. Where this is congruent to this. I know RE, that's this part, is 12, and I know the full thing across is RT, which is 4x plus 7.
Equal. So 12.
If that's 12, that's
12.
12. 12 plus 12 is equal to 4x plus 7. Part plus part equals whole. 12 plus 12 is 24, equals 4x plus 7. And from here, it's just solve. You'll notice that I'm going through the solving faster because we're getting to the point. You've got to know your solving skills. 4.25 is equal to x.
X equals 4.25 over 4.25 equals X.
Indeed. So, sometimes they might do that to you, which we've done on previous problems already today.
So are we done with those?
Yeah.
You should have an equal pass.
Yes, I did get that.
Okay.
Okay. Today we did section 1.3. Ooh, that pen doesn't show up under the doc cam.
Yeah, it does.
If it shows up well enough for you guys, I'll keep writing. That's what I thought. At some angles, it doesn't show up.
It's fine.
For some people, it is. For some people, it isn't.
I must be legally blind.
No. Okay. Homework's due on Thursday. What's happening
We
here
have a
tomorrow?
worksheet.
We got a quiz tomorrow. Just an FYI.